Hi, Will from Fologram here. In this tutorial we're going to look at using the full suite of Fologram for Grasshopper components in order to pick up and move around objects in your Rhino model or in Grasshopper. This is going to use the asynchronous components in order to allow you to essentially store the new positions of your objects after you've interacted with them on the HoloLens. The asynchronous components in Fologram for Grasshopper send data backwards in your Grasshopper model. So if you don't have a really clear understanding of how Grasshopper data flow works, I would suggest you go and look it up a little bit and get your understanding pretty rock solid, because we're really starting to do some pretty strange things here, and the logic could very quickly get complicated and difficult to make sense of. In order to understand Grasshopper data flow, there's some really good resources out there. There is the Grasshopper Primer, which is, if you Google Grasshopper Primer by ModeLab, you'll find that. There's some excellent video tutorials there. There are also tutorials that I've made. They're called the Vimeo XLab, EXLAB tutorials on Grasshopper. There's a few there on Grasshopper data flow, which should be useful for helping sort of develop your understanding of what is going on in your parametric models. So this first tutorial, we're going to have a couple of objects that we'll reference into Grasshopper from our Rhino document. We're going to essentially use the track drag component to figure out where our hand is relative to those Rhino objects. We're going to get the closest object to our hand. We're going to create a vector from where we started dragging to where our hand currently is in order to translate that closest object with that vector and move it around. And then when we stop dragging, we're going to save the position of that object using the asynchronous components. So when we save it, if we start dragging again, we're going to be able to check the position to that, or check the position between our hand and this new moved object, rather than checking the position to where it was in that original list, which is how it would work with typical Grasshopper data flow. All that's going to make much more sense when we actually jump in there and start doing it. So let's fire up Rhino and Grasshopper and connect up your headset. So let's model a few things to move around in Rhino. For the sake of this tutorial, I'm just going to be moving around boxes because they're going to work better. Not very many polygons. That doesn't mean you can't move around much bigger things, but to begin with, let's keep it nice and simple. And I'm going to make sure the box is close-ish to me, so I can pick them up, move them around. Okay, perfect. Now I'm going to reference this stuff into Grasshopper using a geometry component. And for the sake of building a pretty robust definition, I'm also going to use the mesh brep component to mesh all of this geometry. So because we end up having to send geometry to the HoloLens as meshes anyway, there's really no point keeping it as NURBS, so I'm going to mesh it. Now I'm going to store this list of meshed bits of geometry in the async receive component. And I'll talk about why I do that in a little bit, but for the purposes of not having to sort of hack our definition to bits later on and reconnect a whole lot of things, I'm just going to drop it in here now. So the async receive component, all it does is when we plug in some data to this input, it'll store it inside the component and output it again. So it doesn't really do anything that special, but it starts performing its magic when you combine it with the send component, which we'll be doing later on. Okay, so we've got these meshes stored in our receiver. I'm going to now drop down the track drag component. And we want to do a few things. So we want to let's just use the path of the current drag. I want to get the first position of our hand during that drag. So as soon as we start dragging, the first position of our hand will be the first thing in this list. Okay, so if I use a list item component with index 0, this outputs the transform representing where our hand was when we started doing the drag. A little bit of a clever trick to get the last position of our hand during the drag is to zoom in on this component, hit the plus, and then the -1th thing in the list, if you have wrap turned on, will give you the last item in this list of hand positions. So now our list item component is giving us the first location of our hand and the current location, basically, the last thing in this list. Okay, so next is we want to check to see where our hand is and find the closest one of these meshes to our hand in order to just move that mesh, right? So we're going to use a mesh closest point component. We also need to transform, I've forgotten this, we've got to transform an XY plane with all of these hand positions. So I'll just patch that around a little bit. Great, so now we actually have planes that we can use. So we're going to find the closest point on each one of these meshes, and then we'll do some funky stuff in order to figure out which one of all of those closest points is the closest to our hand. So the meshes we want to search are all of these ones in our receiver, and the point to search from is our hand position. Now before we do this, actually, I'm just going to disconnect it. We've got to be a little bit careful. We've got to think about our data flow. So at the moment, the track drag component, it's going to update a whole lot of times while I'm dragging my hand around. I only want to perform this closest point search once when I start dragging. I don't want to be picking up my object and moving it around, and as my hand gets closer to another object, stop moving one and start moving another one. Or perhaps that is what you want for your application. It's not what I want for this one. I only want to do that closest point check once when I start dragging. Now, if you remember that last tutorial where we basically checked to see whether we'd finished dragging before we saved the curve that we'd just drawn, we used the DataDam component to do that, and we're going to use exactly the same component again here to only perform this closest point search once. So I'm going to use the DataDam, and we're going to have to connect up a couple of inputs to this guy. So if we zoom in on the component, we can hit plus, and we can add another bit of data to dam with the component. I'm going to rename these inputs as well so that it's not just Grasshopper Mumbo Jumbo. I'm going to call one hand pos and the other one mesh geometry. Let's call it models. And we'll rename the output as well, just to make sense of everything. Okay, so our hand position, that is the first item in our list of hand positions. That is where our hand was when we started dragging. We want to use that as the hand position to perform the closest point search with, and then we connect up our list of meshes here. Now the boolean to allow the data to pass is I want to do that once when I start dragging, so I can just connect the state up here, bam, but I only want it to be allowed through once. So I'm going to right click on the component and choose allow once. So now these two outputs here will only update once when I start dragging. Really, really convenient. Okay, so we can use that for the mesh closest point search. So the point to search from is my hand position. You'll notice that we're using a plane here. When you connect that up to a point input, it just uses the origin of the plane, and then our list of models as the meshes to search. So you can see here it's generated in Grasshopper, a point for each one of those meshes, which is closest to my hand. Next thing that I'll need to do is to figure out which one of these points is actually closest, because we have a list of points here. So I'm going to use the distance component to find the distance from my hand position to each one of these points. Okay, so now I have a list of numbers, and then I'm going to sort that list of numbers. And at the same time, I want to sort the list of models. Move this around a little bit so you can see it. And for reasons which will become apparent in a second, I also want to sort just a list of numbers add another input here in order to tell which, like the index of the mesh which I want to move. Right? Now, why we do that will become apparent in a second. And actually, we don't really need to sort the meshes. We could just use a list item component in a second. So let's keep it really, really, really simple. And we'll just sort a list of numbers. Okay. So what this does is it sorts the distances. Okay. So this is one distance for each mesh. Sorts them from smallest to largest. And it also sorts a list of like just indices from in exactly the same shuffled order. Okay. So now we know that the closest mesh, which has a distance of 204 units away, just happens to also be the first mesh in the list, but that might not always be the case. So I'm going to use a list item component to grab the first thing in the list. So that gives me the index, just to remind you what this is. That is the index of the closest mesh. Okay. So I can use another list item to grab that closest mesh. There it is there, it's closest to my hand, perfect. Then I can use a move component to move that mesh with a vector from where we started the drag to where our hand currently is. Okay, now it's going to move around as I move my hand. There it is, moving the mesh. And then when we stop, we want to replace, when we stop dragging, we want to replace this moved object replace the unmoved object with the moved object and send it back here to our receiver. So our list of items is the models. The item to replace with is this moved object. The index is the index of our closest mesh, and that's going to replace it. So now we can hide all of this stuff because, and I'll hide everything in Rhino as well. Oops. We now have a list, and as I move things around, you can see it's showing me the saved position. So if you have a look at what's happening here, when the track drag component updates, we get a position of our hand. That will request, or that'll update our data dam with the original list of meshes, which we specified from Rhino. So that's the original positions of all of the boxes. And then we're going to go through, find the closest box, move it using this relative position between where we started the drag and where our hand currently is, and then move the box. So as soon as we stop dragging, basically we lose the position of that box. We forget about it because our definition is using this original list of box positions in order to find the closest box and move it around. So what we want to do is we want to actually change this list of box positions here, which in such a way that it includes the box which we've just moved, so that when we perform the next drag, we're checking these new positions of the boxes instead, and we can then iteratively keep moving a box, picking it up, moving it around. So to do that, we use the async send component, which sends data backwards to the receive component in our definition and updates the values in this list. So rather than the values in this component being set from an input downstream of the component, or upstream of the component, sorry, to the left of it, they're set from a component downstream, our sender way back here, okay? And this is a way of building in memory into our model. So the data that I want to send is this replaced list of mesh boxes, right, which has our new moved box in it. The Boolean allowing data to be sent, I have to be really careful here. So I don't want to be updating my box positions all of the time. I only want to send that data through again once when I finish the drag, right? So I'm going to create a Boolean using the state of our drag back here, and I'm going to invert it. Okay, so that's only going to be true when I stop dragging. And then rather than sending through always, I'm going to send it through to allow once. And now this component here is going to update once when I stop dragging. Okay. Now here's where the little bit of magic happens. This pink box around the component, that's sort of like another parameter, another output. And if you click and drag on the pink box, you can snap this component onto the receiver, and that defines how the data is sent backwards through your model. And we're going to need a few send meshes components here. So I'm going to have a send meshes component for my moved box with, let's make it green, and also a send meshes component for all of my box positions, and I'm going to make that white. Okay, so now I can see all of my boxes on the HoloLens, and if I pick up and move a box around and let go, we're able to then move that box. Now there's a little bit of an issue here in the sense that while I'm moving this green box around, I can still see the original position, but it does at least let me pick up and move boxes over and over again. Okay, now ways to extend this definition. There's a couple of things you might want to think about here. What is actually doing the moving is just this vector between the relative position of our hand at the start and the end of the drag. Now you can manipulate that vector however you want in Grasshopper. So for instance, if you wanted to be able to drag things around but snap them to a grid, you could round that vector back to the nearest grid dimension that you want. If you wanted to move something but have it only be able to move along a predefined rail curve, you could say take your hand position, find the closest point on a curve, and then create a different move vector from that. There is really a whole lot of things that you could do to customize how this sort of moving application works just by using typical Grasshopper components.